Blitzer 5.3, double angle and half angle formulas. So the double angles especially are some of the more important ones that we're going to learn in this chapter. They're ones that we really need to know that you're going to use a lot in calculus. So our double angle formulas are at the top. You'll notice for cosine, there's 3 different ones that you can use. I usually just use the first one, but there are other options. So in example 1, they're telling us to find cosine 2 theta. So in number 1, they're kind of telling us you have to use this double angle formula. So we know that the cosine of 2 theta, and I'm just writing it down, is cosine squared theta minus sine squared theta. And I know some things about theta, right? I have a trig ratio, so I don't know the angle, but I know 2 sides on the triangle. And it says quadrant 2. So I'm going to go ahead and draw it in quadrant 2. And here's my theta. So if my sine is 5/13, y is 5 and 13 is r, and it's Pythagorean triple, so the third side is negative 12. Negative because it's that negative x direction. So now I'm just going to go ahead and plug in and find the cosine of theta and the sine of theta and square them. So my cosine is my x over r. So cosine would be negative 12/13. And we got to square it minus my sine, which I already knew. I guess really we could have used 1 minus 2 sine squared theta. We wouldn't have had to do any work. And we get 144 over 169 minus, this one's squared also, 25 over 169. And this is going to be 119 over 169. So the second one, they're also telling us find sine 2 theta. So we know that sine 2 theta equals, and you can see it right up here at the top, 2 sine theta cosine theta. So this time we're going to have to find the sine and the cosine again. And we're in quadrant 3. So my tangent is 3/5. That means my y is 3 and my x is 5. And they'd both be negative, but negative over negative is positive. That's how it can still work in quadrant 3. We need to figure out the third side on our triangle. So Pythagorean Theorem, it's going to be the square root of 5 squared plus 3 squared, which is the square root of 25 plus 9, which is the square root of 34. So here's my theta, my right angle, and my third side on my triangle, my r side is square root of 34. So now we're just going to plug everything in again. 2 times my sine, and my sine would be y over r, so negative 3 over square root of 34, times my cosine is negative 5 over square root of 34. And this is kind of nice because we multiply those square roots together. And in our denominator now, square root of 34 times square root of 34 is just a 34. In the numerator, 2 times 3 times 5 is going to be 30. It'll be positive, and then we do need to simplify our fraction. So 15/17. So for example 3, they're just asking us to simplify. So we're not asked to evaluate or anything. So this looks a lot like my cosine 2 theta formula up there. Cosine 2 theta is going to be cosine squared theta minus sine squared theta. So this matches up with that theta part. So I can simplify this as the cosine of 2 times 10x, right? 2 times whatever theta is, which is the cosine of 20x. So they're going to be somewhere you're simplifying. On the next one, find the exact values. Exact value means we've got to use these identities or some kind of magic. We're not using a calculator. And so we're always looking, what if I multiply the angle by 2? What if I divide it in half? And so we're going to use sine 2 theta equals 2 sine theta cosine theta. So if this part matches up with the theta part, then I could do sine and I could double that. So we start out with 2 sine 67.5 degrees, cosine 67.5 degrees. But we could make this the sine of 2 times 67.5 degrees. And we know we kind of need to double it, right? Because it's a 0.5. So that's kind of the only real option we can come up with. 67.5 times 2 is the sine of 135, which we can totally do. So now we're going to go ahead and draw that out. Here's 135. So I have a 45-degree triangle. So 1 square root of 2, or square root of 2, square root of 2, 2. And so my sine, oh, and this one's going to be negative. My sine is going to be square root of 2 over 2. So these are all my double angle formulas, just kind of playing around with those. And I am definitely trying to highlight the kinds of problems that you'll be doing in quizzes and tests later on. Power reducing is the next really important one. So we're kind of doing the more important stuff today. 5.2, you're not going to necessarily see very much on Canvas. But here is our 5.3 stuff power reducing formulas. So first we want to reduce the power of cosine theta to the 4th power. So I'm going to start it over here where I have space. I know it's going to be a long one. So cosine, if I have to the 4th power, that means I've got squared and I've got squared again, right? I need this to be squared so I can use my formula. And cosine squared theta I can write as 1 plus cosine 2 theta all over 2. And that entire thing's being squared. So now I would need to go through and actually square it. So when I square in the numerator, I'm going to have a 1 plus. Then the middle term is 1 times cosine 2 theta doubled. So that would be 2 cosine 2 theta. And then the last term squared would be cosine squared 2 theta. And I've got to also square my denominator, so it's all over 4. And then I am going to go through and I'm going to kind of split up that denominator and I'm going to make it 1/4 plus 2/4 would be 1/2. And then plus 1/4 cosine squared 2 theta. So the problem is I still have a cosine squared theta. So I'm going to use this power reducing thing again. So the power reducing says whatever my angle is here, I take it and I've got to double it. And then I have 1 plus cosine double that angle divided by 2. So when I break this up now, I'm going to have a 1/4 out here. This is going to be 1 plus cosine 2 times 2 theta all over 2. I'm writing down everything else. So now, ooh, and I'm running out of space too. So now I want to distribute 1/4 plus 1/2 cosine 2 theta plus, maybe I should wait and work inside first. So this is going to make a 1/2 plus a 1/2 cosine 4 theta, and then distribute, so plus 1/8 plus 1/8 cosine 4 theta, and I am just like out of space here. I'll have to put my final answer on the left. So my only thing I can do though is add my 1/4 and my 1/8 together, and 1/4 is 2/8 and 1/8, so that would be like 3/8, and then we'd have plus 1/2 cosine 2 theta plus 1/8 cosine 4 theta. So that would be my final answer on that one, which I did not quite squeeze in there. And last are our half angle formulas. So half angle formulas, there's a plus or minus. You're going to choose plus or minus depending on, so choose plus or minus depending on which quadrant alpha over 2 is in. So this is the tricky part. And that's why we want to make sure that we just try one of these really quick. So 6, again, they're telling me find the exact value. I've got 165. If I double it or if I have it, we're always looking at those kinds of things. So what if this was something divided by 2, right? We're going to try using our half angles. So what if this was really cosine of, what is 165 times 2? Let's see, that would be 330 degrees. 10, 13, yeah. So let's write this as cosine of 330 over 2. So then I could use this formula. So let's not worry about the plus or minus for right now. Let's just see if we can plug this in and then we'll decide if it's plus or minus. So this would be 1 plus the cosine of 330 degrees all over 2. And then it says look at your alpha over 2. So 165 is in quadrant 2. And your cosine is negative in quadrant 2. Because remember, cosine is like x. Is negative in quadrant 2. So since cosine is negative in quadrant 2, that means I need to have the negative here. So now it looks like I cannot move my page up anymore. So 330, I'm definitely going to have to draw out. So let's go ahead and do that. Do that over here. We haven't had one over in this quadrant in a while. So here's 330 degrees. So it would be a 30 inside. So we would have 1, negative 1, square root of 3, and 2. And when we do our cosine is square root of 3 over 2. So let's see, where can we put this? I'm going to erase over here. And then we'll start over here again. So this is going to be negative square root 1 plus. So the cosine we've decided is root 3 over 2. And this is all over a 2 inside. So if I'm going to add these together, I need a common denominator, or maybe we should divide them both by 2 for now. So I really have 1/2 plus square root of 3 over, if I'm dividing by 2 again, or dividing by 2, multiplying by the reciprocal, it's going to be over 4. So then I want to make a common denominator. So this is going to be 2/4. Oops, and I rewrote that wrong number there. This is not there, 4. It's weird to have a square root inside a square root. I'm with you. And then back up over here. I had plenty of room on my paper when I was doing this, but not so much now. And then I can't take the square root of my denominator, so I want to do that. So now my root is only in my numerator. And the square root of 4 is a 2. So you're going to get sometimes some of these funky like square root inside a square root, and we leave them. That's just the way they look. So this is our 5.3 notes.